Hello student, welcome to Study It Out. In this question, it is given that a 10 centimeter long wire lies along y-axis. It carries a current of 1 ampere in positive y direction. A magnitude value is also given, exists in the region. We have to find the force on the wire. So few points we have to keep in mind. First is the wire is along the y-axis. So if we consider this is the wire, it lies on the y-axis. So if we have a three-dimensional figure, let's take this is y-axis, this is x-axis, and here is the z-axis. And the magnitude of this wire is given as 10 centimeter. It can be written as 0.1 meter. But this is the magnitude. If we write the vector form of this length, so L vector is equal to 0.1 meter with j cap. Why? Because the length is along the positive y-axis. Current is also passing through it, and the magnitude of this current I is equal to 1 ampere. Now we have a magnetic field, and its magnitude as well as direction is given. So it lies along y-axis and z-axis. It means that the magnetic field lies somewhere in this region. Somewhere this is the direction of magnetic field, because we have j cap given and the k cap given. So based on that, zy plane is where the magnetic field lies. Now we have to find the force, how much force on the wire. So to solve the question, we can use the formula F is equal to ILB. So this is force is a vector quantity. So length we take the vector component and the magnetic field as the vector form. And now we substitute the value. I is how much? 1 ampere. Length is 0.1 j cap. And the magnetic field is, it's given as here 5 millitesla j cap minus 8 millitesla k cap. So we write the value 5 mt j cap minus 8 mt k cap. So to solve this problem, we definitely have to understand the concept of cross product of a vector. So in cross product, let's take this is the I cap, here is the j cap and the k cap. So in cross product, if we go with the anti-clockwise, we consider it as a positive. It means that I cap into j cap is equal to k cap. Here again anti-clockwise, so j cap into k cap is equal to I cap. Means whatever the two axes you multiply now, its product will be the third axis, and it is considered as anti-clockwise direction, so it is positive. Clockwise if you consider, it become negative. It means that if you do k into j, so it will become minus I cap. So similarly this one, k cap into I cap is equal to j cap. And what will happen if you multiply with the same axis, unit vector like I cap into I cap, it will be 0. J cap into j cap, it's also 0. K cap into k cap, it's also 0 here. So let's look into that way. Here in this problem, we have to multiply 1. If you multiply, it will remain as it is. So we can skip this part and directly we can write F is equal to 0.1 j cap cross 5 mt j cap minus 8 mt k cap. So 1 by 1 if we multiply, so force is equal to 0.1 into 5 mt, and here j cap cross j cap. So what is the value of j cap cross j cap? It's equal to 0. So this whole term will be 0. Then next minus 0.1 j cap into 8 mt k cap. So F is equal to minus 0.1 into 8 is 0.8 mn, and j cross k is equal to, so here you see j into k is equal to I cap. So we can write this part as f is equal to 0.8 here minus mn I cap. So this is the answer of this question. So if we see the option, here option B is matching. So option B is the correct answer for this question.